Okay, we are doing chapter 4. First thing on chapter 4, do you remember when we'd give you a picture and say, this is f of x? What was f of the absolute value of x versus what was the absolute value of f of x? There's a picture for that. It has to do with like reflecting things and maybe wiping out parts of the graph and replacing them with other stuff. So I'm going to see if you remember how to do absolute values of graphs. Pause for a second. Let me give that a shot. Okay, here we go. You should have said that this one, you absolute valued the x's. The x's are where on this graph? They're in this kind of neighborhood right here. Here's where the negative x's are. You know where I'm going with that? That's where the negative x's are. Because when you absolute value them, now they can't be negative anymore. All right? So that means you're going to take all of those out, and when you feed in a negative number like -2 goes in here, it's going to fool the function and think you put in +2. And that's why this goes up, finds out the answer for that. And so when you put in -2, it thinks you put in +2. That's why this whole thing gets replicated and goes like that. Raise your hand if you had that one as one of your graphs. That's good. All right. And I realized after the fact that this wasn't the greatest graph for this because there's no negative y's. Do you get in my original? My original graph, that little red hat looking thing there, there weren't any negative y's. So absolute valuing the y's doesn't do a thing. The answer stays exactly the same. All right, so let me give you one more and see if you can absolute value the y's on this puppy. I'd like you to tell me what, if this is f of x, if this is f of x, then what would this be? Pause while you figure that one out. Okay, did you say that wherever it was negative would reflect up and become positive? So that stays the same. This reflects up, and it's like the red one I just drew. Raise your hand if you had that one right. Okay, cool. All right. Now, this chapter on graphing also had something called 1 over f of x. It's not the same as what we just did. There's no absolute value involved. Okay. That is the kind where if it typically it'd have a wave, and we go like this and say, what is the graph of 1 over that? Just a hint. When this graph hits 0, the new graph becomes 1 over 0, which doesn't exist, right? So there's asymptotes on this graph. See if you can sketch for me what 1 over f of x would look like. If this guy is f of x, what would 1 over that be? I'll pause for a second and let me give that a try. Okay, did you at least have asymptotes going through where the function was 0? 1 over 0 can't exist. So there should have been asymptotes there and there. Raise your hand if you had the asymptotes in the right spot. Okay, good. Next, where this one gets really small, f of x gets really small, you're doing 1 over something really small, which makes it really what? Really big. And so this is really big. Goes lower, lower, lower until it, where would they overlap each other? When f of x was equal to what? You'd have a special spot. 1. 0 is the asymptote. Where f of x equals 1, that's the spot where they overlap. Now I'm going to call that right here, but you'd have to decide for yourself as your scale, but there you go. Let's say that -1 is right here on this graph. I know that it'd be handy if I had had a scale here, but if that's +1, then the other one, that's about -1. Do you get that as this gets really small, the other one gets really big? And so it's really big down here, goes up, hits that, goes back down again. Next, as this one gets really small and negative, then 1 over it is really big and negative. So like here, and then going down to where it hits -1 again. So it goes till it hits -1. And then as this gets bigger and bigger, this gets smaller and smaller. The blue one is your reciprocal graph. Asymptotes are key. Spots where it's equal to 1 or -1 are key. And the last thought is when the function is really small, less than 1, the other function is really big because you have 1 over a really small number. 1 over 1/10, for instance, becomes 10. It's big. Yes, if this is really small, then your answer will be big. Okay. So let's move on to another topic within Chapter 4. And that was, this is a little simpler, nice little break. So let's go like that. Remember how that spot and that spot are special? What are they called? Local maximums. Okay, how about this guy right here? False. Local minimum. Absolute maximum. Is it A, B, or C? C is the absolute maximum. Where is the absolute minimum? Doesn't have one. You don't say it's negative infinity. You say it doesn't have a minimum. It never stops. Never hits a low spot. Okay, how about between B and C? Let's say the B is the point 8, 2, and 16, 18. If it's 8, 2 to 16, 18, how would we say that it increases in that interval? It increases from where to where? And no, you can't say 8, 2 to 16, 8. Or sorry, 16, 18. You'd say it increases in this little green zone here. But I say it increases between 8 and 16. We use the X numbers. You say it's increasing between here and here. Okay? So, tell me about what's happening between A and B. It's decreasing between what and what? Between 0 and what? Between 0 and 8. So in this little zone right here, it's decreasing between 0 and 8. Because this is at 0, I don't know what that is. Maybe that's 16. Maybe this is 12 or something. That spot right there, 0, 12. So you take the X numbers of it and say it's increasing or decreasing between 0 and 8. What? If they asked you what was the maximum, you'd say the maximum was 16, 18, or you could say the maximum was, absolute maximum, was 18 at the point 16, 18. All right. Okay, next thing on those kind of squiggly graphs, do you remember how to find the X-intercepts? The X-intercepts are, finish that sentence, where y equals 0. Okay, so here's an X-intercept, here's an X-intercept. Those are also known, they have 4 names. The X-intercepts, the zeros, roots, solutions. Good. Okay, with the Y-intercept, well in this case it's at A here, which is at 0, 12. The Y-intercept is where what? Where X equals 0. The Y-intercepts where X equals 0, and the X-intercepts where Y equals 0. Okay. Suppose the point 4, 8 is on f of x. 4, 8 is on my function. what if I do this? 12 minutes left, which is, we're going to go right to the end of the hour this time, so it gives me a 12-minute warning. Suppose that's on my function. The question is, if I take my function and I do this to it, my g of x function is going to be taking my f of x function and adding 3 like that. It shouldn't be too tough for you to tell me a new point that would have to be on my g of x function. So if 4 comma a is on f of x, and g of x is given by taking f of x and doing that to it, then what's my new point on g of x? I'll pause for a second when you consider that. Okay, that was pretty simple. You're probably just thinking to yourself, okay, Mr. Server, you just took the point and you moved it 3 to the what? 3 to the left. And so this point just became, go 3 to the left. That's the x of it, right? And so if I go to the left, that's not going to mess with the y. It's going to mess with the x. I'm going to the left 3. Okay, so that's going to be 1 comma 8. Raise your hand if you had that one right. Okay, good. Now, do you remember then that that means you could have set this equal to that? Does that ring a bell? That x plus 3 is 4, and therefore you solve and you get x equals 1. We'll see if you remember this even better then. So what if I say my g of x function is given by 3 f of 2x plus 1 minus 2. What's the new point now? Remember, I just showed you a way, and I wasn't doing that just for fun. It works. That goes with something. I'm going to pause while you think that one through. Okay, let's talk it through. So you have, this is where your x goes, right? And they're saying that that's 4. So 2x minus 1 has to equal 4, and you just solve it. 2x has to equal 5, x has to equal 5 over 2. Raise your hand if you had that one right. Uh-oh. I'm lost. Oh, okay, I got you. That's, I just miscopied. That's a plus. So then I'm subtracting 1, and then this would be 3, and then it's 3 halves. How about that? How many had 3 halves? Okay, good. Sorry about that. Oops. Notice some of you made the same oops. Okay, now the other part is that if x usually goes right there, where does y, what represents y in this function? F of x. All of that is the y. So that's the y. So what is y? It's 8. So you go put the 8 right there, and you get 3 times the 8 minus 2. 24 minus 2, 22. So we have 3 halves, comma, 22 would be your new point that would go with this one. Raise your hand if that made sense to you. Okay, good. All right. But wait, there's more. In this chapter, we also covered odd and even functions. So, do you remember those little rules for being odd or even functions? Is that even or odd? And don't just say, oh, because it's got a power of 2, it must be even. No, there's a fancy way of proving it. If f of negative x comes out the same as f of x, then you've got something that is even. If f of negative x comes out to the same as negative f of x, you've got something that's odd. So do it and figure out which one's which. Well, f of x is really obvious. We got f of x, says it right there, 3x squared. How about f of negative x? Well, you take 3x squared, and instead of x, you drop in a negative x, and you see what happens. Yep. To compare these two, negative f of x is the opposite of the function, which is this. And f of negative x, that's the same exact thing as I have here. Yes. I'm just going to show you this way, because I had a lot of kids get it wrong last time. I'm going to show you two different ways to do it. So this, you will need to know the even rule and the odd rule, and this is an important one. I usually do it this way. Oh, it's got negatives on both sides. That's odd. Whereas this one only has the one negative. Notice they both start identically. So write these rules down. Something for you to memorize. So will definitely help. Okay, so now I'm going to simplify this. Negative x squared comes out to just x squared, so it's 3x squared. And this comes out to negative 3x squared. Are these the same? Simple question, are those the same? You're saying 3x squared is the same as negative 3x squared? No, they're not the same, so it's not odd. Now we'll go to the other side. This one, 3 times negative x squared, and that's going to be 3x squared when it simplifies. And this is just 3x squared. Are those the same? Yes, and therefore it is an even function. What if it wasn't even and it wasn't odd? What do you call it then? Neither or neither. Depends on which way you like to put the emphasis on your syllables. How many of you say neither? Who says neither? Do you have a plan for your neither versus neither? Okay, fine. I agree, though. I sometimes feel like I pull out whichever feels right in the context. All right, so let me give you one more like this, and I'll do that triple chart on this one. See if you like this better. 6x squared minus x. And my question is it odd, even, or neither? I'll do this with a triple chart. What's the one that overlaps that they both had in them? Both the even and the odd rule had f of negative x. Good, I'm putting that in the middle. F of x is on the left, f of negative x, and the last one is negative f of x. Now, this is important. These two, do they make odd or even? That's what everybody got goofed up on the test, is if they saw those two as being equal, then they got confused on which one was odd and which one is even. Okay, it's got two negatives. Oh, that's odd. Okay, that's the odd one. If these two are equal, then that must be even. What if the outside ones are equal? Then that means nothing. Doesn't mean a thing. All right. Pausing for a moment. All right, so you should have stuck in a negative into this function. And if I do, I have 6 empty spot squared minus empty spot, negative x, simplify it down, 6x squared plus x. Now, this is the easiest thing of all. F of x is just given. It's right there, so I put it right there. 6x squared minus x. Is that the same as that? No, and therefore this thing is not what? Even. Now on the other side, I'm trying to see if this is the same as that. So negative f of x. This one's complicated because you need to put a parenthesis around it. Otherwise, you'll think, here, do you get, kids will copy it down here, 6x squared minus x, and then they'll say, okay, so I want opposite of that. So I put a negative there. See what I'm saying? And then these parentheses around it. Otherwise, you'll only be taking a negative of the first one. All right, so now negative x, 6x squared plus x, is this the same as this? No. And therefore, it's not even and it's not odd. So it's a neither or a neither. Okay? All right, so that's showing whether things are odd or even or neither. But wait, there's even more. All right, this is the fairly easy stuff. Do you remember if I do this? I could say where this has been changed. It's been moved to the right, this, and shrunk that, and multiplied or stretched by this. Okay, there's 1, 2, 3, 4 things in order. I personally always start on the inside. And when you're on the inside, do things act in the normal order of things? No, you can't trust things on the inside. Hope you can still picture me describing the guy in jail. Then, I'm going to let people try to figure that out. On the outside, though, you can trust things that are on the outside, so it goes in normal order on the outside. All right. So if I'm starting on the inside, it's either the 3 or it's the -1. Now, multiply by 3 is normally first, so it's not first. The -1 is first to be right 1. And that 3, which seems like it's horizontal stretch of 3, is not. It's a horizontal shrink, and you don't say 3, you say 1/3. Then you move to the outside, and this is twice as vertical. So vertical stretch factor 2, and the last thing is up 5. And that's in the right order. All right, that's enough review there for Chapter 4.